Hello, today we're going to be looking at sequences series, specifically arithmetic and geometric sequences in series. So let us look at this problem. Tiffany, a medical student, comes out of college with $161,250 in debt. Her initial monthly payment is $375 and she later pays $25 in addition to her monthly payment. Luckily, she landed a residency that paid her $4,000 for the first month, which later increases by a rate of 0.5 every month. How many months will it take to pay her debt off, and how much will she have to pay after she pays her last monthly payment? So the first thing that we need to do is look at the first part of the question. How many months will it take to pay off her debt off? So, we need to look at the information about her debt. Her monthly payment is $375, and she later has to pay $25 in addition. In addition is a tip-off to telling us that it's a arithmetic series and sequence because it adds $25 to her previous monthly payment. So, in order to find what we're looking for, we're going to be using the partial sum equation for arithmetic series, which is n over 2 equals quantity of 2a plus quantity of n minus 1 times d. We know that we're going to be using partial sums because we are looking at a part of the entire sum. And we're not looking for an infinite series. We're looking finite sum, which is we're looking for a certain amount of terms. So, since we're looking for n terms, we need to find the other variables, a and d. We need to know those. And we know a, which is 375. Since it's an initial monthly payment. No D, because we need to add 25 to each monthly payment. And D is the difference. So we need to plug in these variables and set the equation to equal the amount of debt she has to pay off, because that is the sum that her payment should equal. So once we have the equation, we set it to equal 0, and as you can notice, it becomes a quadratic equation. What we can do with this quadratic equation is we can plot it. What plotting will tell us is we can look at the x-intercepts, and these will give us the answers for what x is. So what we can do is we can plot. Here we are, x squared plus 29x minus 12,900. And we can plot this. This is a quadratic equation, so it should be a parabola. Since we are looking at a small window, obviously we cannot see the entire parabola, since the x and y-intercept is all the way down at 12,900, negative 12,900. So instead, we can just look at the zeros, which is what we need to focus on. So in order to find the zeros in one plot, you can click here and mark this point, and move on to the next point, and mark that point. So we have two possible answers, one at negative 129 and one at 100. Obviously, we can't go back in time and say that it's negative 129 months, but we know that now it has to be 100 months. So we've answered the first part of the question. It takes Tiffany 100 months to pay off her debt. And the second part of the question is, how much will she have left after she pays her last monthly payment? So, we look at how much she's paid. She's paid $4,000 for the first month, so this is the first term, and this increases by a rate of 100.5%. A rate is a ratio, or it can be used as a ratio. And since it is a ratio in this sense, we can say that we are looking at a geometric sequence in series. So in order to find the partial sum for the geometric series sequence that we have looked at right now, we know that the rate is 0.5. So let's go to Excel. So 0.5, here's the first term, 4,000, and 0.5 is the percentage, and we need to convert this back into just number. And now I'm going to add 1 because we want to add 0.5 of the previous term to the previous term itself. Otherwise otherwise the numbers would just get smaller and smaller, and that's not what we're looking for. Her salary increases by 0.5, so we add a 1. What we can do is take this first term and multiply it by this rate. And all we need to do in Excel is just drag it all the way down to 100. And then we can take this C, and we need to drag it all the way down in order for the function to follow all the way through. So we drag it all the way to 100. Since she's only getting paid 100 months, and we're looking at her payment at the end of each month. And so we find the sum, because that's what we're looking for. We're looking for how much she's paid in total. And we take this total, and then we subtract it from her, we take her debt and subtract it from this total, and she ends up having $356,000 and $356,085 left to use for the period of 100 months that she's being paid and that she has paid off her debt. Now we have answered the second part of the question. And we can graph these values, and we should get a slightly exponential graph. It looks more linear because the ratio is so close to 1. However, it is actually exponential because it is greater. And if this were to be expanded, you can see that there is a slight curve here, and it is true to what we have. Geometric series do have a curve because they are exponential and not linear. But since this value was so close to making the equation linear, it looks like it is a linear equation.